With its breathtaking fjords, its marine wildlife, and its ocean bounty, the British Columbia coastline is a jewel of nature. This coast may also produce a new kind of harvest, renewable energy from waves traveling across the ocean.
There is a tremendous amount of power in an ocean wave.
If we could just harness the energy in those heaving waves.
Could the movement of waves help us reduce our reliance on fossil fuel? Researchers are trying to channel this fierce and very challenging force of nature. In Sauk Harbor, a team from the University of Victoria is loading a strange-looking device.
Hold up one sec.
It's a high-tech buoy packed with electronic sensors that monitor the movement of waves. Researchers will deploy it off the coast of Vancouver Island to assess the wave energy potential of our shores. Engineering professor Brad Buckham directs the research program.
Well, the magnitude of the supply is tremendous. We've made electricity from water for a long time, so it's not such a great leap to think that you would make it off of a wave.
Wind and solar power technologies are already well established and increasingly used around the world, but they can't generate electricity all the time.
If we built a gigantic solar plant, well, where we're standing right now, it would be fantastic today. It would solve all of our problems today. Tomorrow, maybe not so much. But tomorrow the clouds roll in and the waves come up, and there's another source of renewable energy that we can tap into.
Water is 800 times denser than air, so waves can carry more energy than wind per volume. Global winds are pushing waves across the Pacific, bringing them to our shores packed with energy. A meter-wide section of wave can provide 40 kilowatts. That's enough energy to power about 20 homes.
You extend that over a kilometer, now we're 40 megawatts. You extend that over 25 kilometers of coastline, now we're looking at around a gigawatt of capacity, which is a typical hydroelectric plant in British Columbia.
1 gigawatt could fill the consumption needs of a city the size of Winnipeg. The first targets would be more modest. Remote coastal communities that are still relying on diesel to generate electricity. But with such great potential, how come this resource is still untapped? Since the 18th century, inventors and engineers have been trying to come up with the perfect device, so it's not a new idea. Some designs were quite elaborate, but few actually worked. With its pounding swells, punishing winds, and corrosive salt water, the ocean is a very challenging environment. To see how modern engineers are trying to find new solutions, we went down the coast to the state of Oregon. It's the hotspot of wave energy research in North America. Oregon State University engineering professor Annette Von Juan has been one of the pioneers in the field since the late 1990s.
I started writing a lot of proposals to advance wave energy, and you know, at first, sometimes you can hit a bit of a brick wall, a bit of a sentiment that, you know, she's kind of crazy if she thinks devices are going to survive out in the ocean.
But despite the skepticism, Von Juan was convinced she could find a way to capture wave energy using more modern technology like electronics and fiberglass. Her team came up with a simple concept requiring little maintenance: a buoy that generates electricity by bobbing up and down in the waves. Von Juan took it home to her small exercise pool to make sure it floated. But could it take waves? She went to the local wave pool to find out.
They actually generate pretty substantial waves there. And so I realized the opportunity for us to have it moored to the bottom of the pool using weights. And we were able to get in there early Saturday mornings before all the rest of the kids arrived and test it.
When Von Juan's team were testing their design in the mid-2000s, several others were already way ahead. At first, it seemed like a modern-day gold rush. In Europe, a company named Pelamis tested this giant sea snake, but the company eventually ran out of funds. In Oregon, US-based Ocean Power Technologies announced plans to install several of these buoys off the coast, a wave energy farm a few kilometers from the shore. Underwater cables would carry electricity to 1,000 homes. But it abandoned its Oregon project over permit issues, even though it had finished building a complete device. Even a Canadian company joined the race. In 2007, BC-based Finavera Renewables tried its Aquabuoy prototype in Newport on the Oregon coast. But things went south. After a 2-month trial, the buoy sank because of a pump failure. Even if it was later retrieved, the incident raised some concerns among local crab fishers like Bob Eder.
It was a good example of how not to go about it. The buoy was thrown together probably a little too hastily. It wasn't seaworthy. It sank before they could retrieve it, and it stayed on the bottom for many, many months. We'd hate to see abandoned failures on fishing grounds or anywhere on the ocean.
A company like Finavera, to receive that federal funding and to meet the commitments that they were obligated to do to their investors, perhaps you could say had to go too fast.
Despite some industry failures, many researchers like Von Juan continued to push ahead undeterred. Her team took a slower approach, seeking simpler designs using unsinkable materials. Her device looked a bit like a donut on a stick. No hydraulics or pistons that could break down. A coil and magnets did the trick.
As that float heaves up and down, it's heaving that magnet assembly up and down, creating that changing magnetic field. When the coils in the spar experience that changing magnetic field, voltage is directly induced.
In 2008, her team took the prototype out to sea, and it worked. That light bulb was powered by wave motion. Still far from lighting up a whole town, but that's a challenge several of our graduate students were ready to take on, forming their own company, Columbia Power Technologies. They made hundreds of changes using computer models and simulations, tweaking the shape until it performed well in virtual waves. But computer simulations have limits, so they built small-scale prototypes. This is where they come to put them to the test. Oregon State University's Tsunami Wave Basin, one of the largest and most sophisticated wave tanks in the world.
Tim, we're ready for the next run.
Okay, trial 21, this is 4511. Wavemaker started.
The basin is on a scale 33 times smaller than reality. The small-scale model is attached to the bottom with mooring cables. It has 2 floats, each connected to its own generator inside the body. The more the floats move, the more electricity will be generated, says engineer Ken Reinfrank.
Now we're running, and these are 4.5 meter waves. You're seeing, really nice motions on the floats right now. It's really encouraging to see the buoy this active. It implies that it's able to make more energy.
These are exciting waves.
Oh, we were way off.
Yeah, we were.
That was a factor of 10 less than what they predicted.
That's good.
At this point, wave energy would cost more to produce than other types of renewable energy, but proponents believe this would change once an industry develops.
The wind industry saw decreased costs as you saw increased volume. And so we see that same trend with wave energy, where as we start to develop units into the hundreds and thousands, that then we will see a significant drop in the cost per kilowatt hour.
But would the arrival of this green technology impact marine life and seabeds? Could it be an obstacle to navigation and fishing? It's a dilemma for Bob Eder, who strongly believes in renewable energy.
So I was excited and at the same time apprehensive about the possibility of its success because we're going to lose space to work. And so I've been real involved in trying to find a path where we can investigate wave energy and do it responsibly.
Von Juan developed a testing center to find answers to those important questions. It's essentially a floating lab where wave energy developers come and try their designs in open waters, while researchers can monitor their impact on the marine environment.
And so for all of this, we need to get some devices in the water in a responsible way, and through that really, learn valuable lessons as to how we can do this in the least impact way.
Back in BC waters, the University of Victoria team takes advantage of calm conditions. They head several kilometers out to sea to deploy the monitoring buoy. 3 other identical buoys have been placed further north along the coast of Vancouver Island. They transmit data every hour back to the university's computers. This helps researchers pinpoint the coastal areas with the best potential. Wave energy is still in its infancy in Canada, and with low energy prices, there's little demand for it right now. But it should be developed along other renewable energy sources, believes engineering professor Brad Buckham.
I think that the situation that we live in right now, factors are going to change. And there is going to be a need to bring in renewable technologies to fill some of our energy demands. They're all going to need to work in some kind of harmony to really have an impact. It's the only way you're going to get up to a scale on renewables where you can mitigate greenhouse gas emissions to a level that will really, really have an impact.
The Pacific Ocean's powerful swells could fulfill the energy needs of some West Coast communities within a decade or two. It may even contribute to the overall power grid, helping us reduce our addiction to fossil fuel. For The National, I'm Frédéric Zalac in Victoria.